Hey there, this is section 11.4. We're going to talk about area of regular polygons today. So just some vocab to go over. The center of the regular polygon, an angle that has a vertex at the center of a polygon and sides that pass through consecutive vertices. You can also see that that polygon is inscribed in the circle, so that center is also the center of your circle as well. The radius of the regular polygons, notice we're using it in terms of a circle because that is kind of what we're going to talk about. The radius of a circle circumscribed about a polygon will also give you the radius of your polygon. So notice AB is a radius of the circle, but it's also a radius of that polygon. Next, the apothem, which is pretty important for us to know because we're going to use that word a lot. A segment that is drawn from the center of the regular polygon perpendicular to the side. So notice AC would be my apothem. If you notice that ABD is sort of like one out of the 1, 2, 3, 4, 5, 6 triangles you could draw in this regular hexagon. Central angle is just the angle that intersects a circle in 2 points and has a vertex at the center of your circle. So if you notice what we just drew right here, this would be your central angle. So angle, let's put it over here, angle B AD would be considered one of your central angles, and to get that central angle you're going to take 360 divided by the number of sides of your polygon. So to get my central angle I'm going to take 360 divided by 6, which would give me 60 degrees. So this entire angle right here is going to be 60 degrees, and that will be important in just a little bit. Composite figures we'll talk about is a figure that can be separated into regions that are basic figures. We're going to use this a lot because we're going to be able to use it for finding areas of maybe some irregular shapes that we don't necessarily have a formula for every single irregular shape. All right, let's just do some little basic labeling. In a figure, our pentagon is inscribed in circle X. Identify the center, radius, apothem, and central angle of the polygon. Then find the measure of your central angle. So my center is just going to be X. So point X. My apothem, remember, is that perpendicular segment from the center to the side. So XN would be my apothem. My radius is really the radius of that circle, so I could say XR or XQ. And last, that central angle, remember, is used from the radii of that circle or that polygon. So that whole entire thing, 2 radii make a central angle. So I'm going to say angle QXR, labeling that vertex in the middle. And then last, to find your central angle, you would take 360 divided by the number of sides, which would be 5. So my central angle would be 72 degrees. So the measure of angle QXR is going to be 72 degrees. All right, flip it over to the next page and check your progress. I got 60 degrees, 360 divided by 6 would be 60. All right, there's a few different ways that we're going to look at solving the area of these regular figures. So here's the first way. The top of the basic table is shown as a regular hexagon with a side length of 3 and an apothem of 1.7. What is the area of the tabletop to the nearest tenth? So since a polygon has 6 sides, the polygon can be divided into 6 congruent isosceles triangles. So notice if I take one of these out, they're isosceles because I know that all radii are going to be congruent. So if I take this out and relabel it, here is my apothem. These are my congruent sides. This is 3 feet. And then 1.7 is going to go right here. All right, I can find the area of one of those triangles. Remember, the area formula for a triangle is 1/2 base times my height. So if you look at that triangle, yes, we labeled this as the apothem, but it is also the height, which we know of a normal triangle. So I can say area equals 1/2 my base, which is 3, and my height, which is 1.7. So one area of a triangle is going to be 2.55 feet squared. But remember, I have 6 of those. So I can multiply the area of one triangle by the total number of triangles. So I'm going to take this number, and since I have 6 of them, I'm just going to multiply that by 6 to get 15.3 feet squared. Okay. All right, why don't you try that same way right below on your check your progress. And here are those that answer. All right, so sometimes it won't always be that easy. We won't always be given 2 links that we need to then solve. So here is a way, another way that we're going to also look to see how to solve. So 3 things we need: the apothem, the side length, and the number of sides. And then this is going to be my formula right here. My area is going to equal 1/2 my apothem times the number of sides times the side length. Again, what we just did, but this is just a formula that you can remember if you would like to do it this way. All right, so I'm going to give you some new steps, 5 steps to solving these regular polygons using this formula. So the first step I'm going to give you is to find your central angle. So I'm not going to move it down just yet, but you can see on your paper that I have 6 sides. So to find my central angle, I'm going to say 360 divided by 6, which would give me 60 degrees. All right, I then am going to take my central angle, because remember on this picture, this entire thing right here is 60 degrees. So what I'm going to do before I keep going, I'm going to take this hexagon, I'm going to break it down into just this triangle. So I'm going to kind of zoom in to this one, and then I'm going to zoom in again, and I'm just going to really focus on this triangle right there. Okay, so that's what we're going to kind of do with the next few steps. So taking that central angle and dividing it by 2, so 60 divided by 2 gives me 30 degrees. And I do that because now if you look at this right triangle, I now have a 30, 60, 90 degree triangle right here. So that would be 30 degrees. All right, my next step is to solve for this right triangle, which means I need to solve for whatever I need. So after I do that, I always off to the side as I'm solving will write down A, N, and S, because those are the 3 things I need for my formula to work. So remember, my A is my apothem, my N is my number of sides, so I do have that, so I'm going to say that is 6. And my side length, my entire side length of my hexagon, which is 5. And that won't always be given, so we'll see how we work those types of problems out. All right, so solve my right triangle. I know that I'm missing my apothem, so I'm going to redraw this triangle over here. This is going to be 30 degrees. This is my apothem, and notice I'm just taking half of it, so I need to make sure I just put 2.5 there. So you can do 30, 60, 90. You can also do sine, cosine, and tangent. So I'm going to use sine, cosine, and tangent because we haven't done that for a while. So I'm going to just write SOHCAHTOA right here. Alright, so notice I have my opposite, I have my adjacent. So I'm going to use tangent of 30 equals 2.5 over A. So since that is on the bottom, I'm going to say 2.5 divided by the tangent of 30 in my calculator. Make sure you are in degrees. So my apothem, and I'm going to, if I can, try to go to 4 decimal places. That will just be safe and give us a much closer answer than rounding once and then I round again and then I round again. Alright, so step 4 was identifying all of our links, which we have all 4 of them now, or all 3 of them now. And now we're ready to just plug in and solve. So my area equals 1/2 my apothem times my number of sides times my side length. So my area is approximately 65 meters squared. Alright, let's try another one with our steps. I think it's helpful to follow those steps every time just to get used to being in a groove. Alright, so my first thing is I need to find my central angle. So 360 divided by the number of sides, which is 5, so that gives me 72 degrees. And right after that, I'm going to divide by 2 to give me 36 degrees because I am going to cut that pentagon into one little triangle, so that gives me 36 degrees. Alright, now I'm going to label. I'm going to use this information over here to label. So this would be 9. So I don't have anything else. So knowing A, N, and S is what I have to have. My apothem I do not have, so I need to find that. My N, my number of sides, I do have that. That's 5. My side length. Notice my side length is AB, but right here I only have dB, so I'm going to call that x. So when you get to solve for s, I'm going to say 2 times x is going to give me my side length. Alright, so let's keep going. That might be a little confusing. So let's first solve for my apothem. So I know that this is my hypotenuse, this is my adjacent, so I'm going to use cosine. So cosine of 36 equals A over 9. Since it's on the bottom, I'm going to cross multiply. Pen will work. A equals 9 times the cosine of 36. So my A is going to equal 7.28. Alright, now I need to find x. So that is sine of 36 equals x over 9. Again, on the bottom, so I'm going to say x equals 9 times the sine of 36. So x is going to equal 5.29. I'm going to multiply it by 2 to get to s already. So my s is going to be 10.58. And then once I have all 3 of those, now I'm ready to solve. A equals 1/2. A, N, and S. If you are not familiar with those SOHCAHTOA things, you probably need to refresh your memory. So my area is going to approximately equal 192.6 centimeters squared. Alright, if you will stop this video and try your checkpoints, make sure you show all of your work just to help you get in the groove of things. Here is your work. And there'll be one more video coming up about composite figures. Thanks for watching.